Dear children, now as we know what combinations are, let us attempt some practical problems on combinations. See this one. It says how many chords can be drawn through 21 points on a circle. So we need to first think how many points are needed to get a chord. We will require 2 points to get a chord. So we can mention to obtain a chord, 2 points are required. And how many points are given? You can see 21 points are available. Now using these 21 points, you have to make maximum possible chords. So this can be done in, therefore, total number of chords obtained using 21 points. This will be equal to C21, 2. So 2 points out of these 21 are going to result into a chord. So this consists of all possible chords which can be made by taking 2 points at a time out of the given 21 points. So if we simplify it, it will be 21 factorial over 2 factorial into 21 minus 2, which is 19 factorial. You can see 21 factorial can be written as 21 into 20 into 19 factorial divided by 19 factorial, and 2 factorial is 2 into 1. So this 19 factorial gets cancelled out. With 2 we can get rid of 20. It will reduce to 10. So the product comes out to be 210. So 210 chords are possible if these 21 points are available on the circle. See the next one now. It says determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. So we have 52 cards, of which how many are to be selected? 5 to be selected. And it has got a condition. The selection has got a condition. It says the 5 cards you are selecting, that should contain exactly one ace. So we can divide 52 cards into 2 categories, that is of 4, one is of 4 aces and other of remaining 48 cards. We can call them 48 non-aces. Now because total number of 5 cards are to be taken out, and this 5 should contain exactly one ace. So that one ace will come out of these 4 aces and remaining 4 cards will come out of these 48 non-aces. So therefore we can say total number of required selections. Required selection means 5 cards containing exactly one ace. So total number of required selections, 2 things are taking place. Ace is getting selected. So one ace will get selected out of these 4, and simultaneously 4 non-aces will get selected from these 48 cards. So we are going to expand both using the formula for combinations. C4 comma 1 will reduce to 4. When you will expand it, it will be 4 factorial over 1 factorial into 3 factorial. So that gives rise to 4 only. Second part, let us solve. It will be 48 factorial over 4 factorial into 44 factorial. So we can expand 48 factorial up to 44 factorial. We can write it as 48 into 47 into 46 into 45 into 44 factorial. In the denominator, 44 factorial you can see will get cancelled out, and we also have 4 factorial, which can be written as 4 into 3 into 2 into 1. So cancelling out the common factors, you can see we can get rid of 4 here. Then with this 2 we can cancel out 48, it will be 24, and with 3 45 can be cancelled out, we get 15. So leftover terms are 24 into 47 into 46 into 15. Now on multiplying this, the product reduces to 788320. Now wherever the calculations will be too large, the total number of selections can be written in this form only. Now taking another example, this one states, it asks, in how many ways can a team of 3 boys and 3 girls be selected out of 5 boys and 4 girls? So what is available? We have got 5 boys and how many girls? 4 girls. This is the given number. But out of these 5 boys, we need 3, and out of these 4 girls also we need 3. So let us make a team. Total number of ways in which team can be selected will be, see, 3 boys will come out of 5. They will be selected out of 5 boys, and 3 girls will be selected out of 4 girls. So total number of ways in which team can be selected will be equal to C 5 comma 3 into C 4 comma 3. So expanding both and solving, this is 5 factorial over 3 factorial into 5 minus 3, which is 2 factorial. 4 factorial into 3 factorial into 4 minus 3, which is 1 factorial. 5 factorial can be written as 5 into 4 into 3 factorial. Keep this 3 factorial as it is. 2 factorial is 2 into 1. 4 factorial can be written as 4 into 3 factorial. We have a 3 factorial in the denominator. 1 factorial is 1 only. Cancel out wherever it is possible to cancel out the terms. With this 2 we can cancel out 4 also. So this is 5 into 2, 10, and which is further multiplying with 4 here, okay, into 4. So it reduces to, if you see, it comes out to be 40. So you can see very well, we can have 40 number of ways in which a team can be selected, where only 3 boys are there and only 3 girls are there. Now taking another one, it says find the number of ways of selecting 9 balls from 6 red, 5 white and 5 blue balls if each selection consists of 3 balls of each color. So you can see we need 3 balls of each color. So 3 red balls, 3 white balls and 3 blue balls are required, and total balls comes out to be 9 when we take 3 from each of them. So we can calculate the total number of selections, total number of ways in which required selection can be done. Number of ways in which required selection can be done. When we write required selection, we are covering the given condition. So total number of ways in which required selection can be done will be equal to, let us start selecting now. Out of 6 red ball, we need to select 3, and simultaneously out of 5 white ball, you have to select 3, and out of 5 blue balls, you have to select 3 balls. Now expanding each of them and solving, this will be 6 factorial over 3 factorial into 6 minus 3, which is 3 factorial only. 5 factorial over 3 factorial into 5 minus 3, that is 2 factorial. This is also 5 factorial over 3 factorial into 2 factorial. Now these 5 factorial over 3 factorial into 2 factorial we have just now solved in the previous question. So we can get to know from here how much it will come out to be. So if you look at this entire calculation, you will see it reduces to 10. So this will reduce to 10, this will also reduce to 10. This part we can solve. It will be 6 into 5 into 4 into 3 factorial. In the denominator we have 3 factorial, and one of the 3 factorial can be expanded. We can write it as 3 into 2 into 1. So 3 factorial gets cancelled out, then 3 into 2 is 6. So this also gets eliminated. So we are only left with 5 into 4, which is 20. Then we have it multiplied by 10 and 10. So the total number comes out to be 2000. So in 2000 ways the given selection can be made. Now, slightly taking a different question, it says, in how many ways can a hockey 11 be chosen out of 15 players so as to include 3 particular players or exclude 3 particular players? So, these 11 players which you have selected, in the first part, we need to ensure that 3 particular players are there in those 11. So, keeping that in mind, the selection is to be done. But in the second case, we need to ensure that out of those 11, the 3 particular players are not at all included. So let us see how it can be done. See, these are the given players. 15 players are available. And how many we have to select? 11 to be selected. Now let us divide these 15 players into 2 categories, where first one will include 3 particular players. We have separated them from the rest so that selection becomes easy for us. So 3 particular players. Out of 15, if we remove these 3, we are left with 12. So we can call them remaining 12. Now look at both the cases one by one, how we will be dealing with them. In the first part, when you are selecting 3 particular players, so they will come from here. So 3 from the first part, and how many from here? See, the total has to be 11. So if these 3 particular players are already included, then we have to select remaining 8. So those remaining 8 will come out of 12. So this is how the selection can be made, 3 and 8, and these 3 from the 3 particular players and 8 from remaining 12. Okay, so the total becomes 11. In the second case, they are saying exclude 3 particular players. So these we are not going to include. None of the player from these 3. That means all the 11 will come from the remaining 12 players. So keeping this in mind, now let us write the total selections one by one. First case, let us take again total number of required selections. This will be C 3 comma 3, because there are 3 particular players, all the 3 are to be taken, and C 12 comma 8. So C 3 comma 3 reduces to 1 on expanding. This we will write down. It will be 12 factorial over 8 factorial into 12 minus 8, which is 4 factorial. So we need to expand it and solve. Let us see what it gives us. 12 factorial we can write as 12 into 11 into 10 into 9 into 8 factorial. This divided by 8 factorial into 4 factorial. 4 factorial is 4 into 3 into 2 into 1. So you can see here 8 factorial is cancelled out. 4 into 3 is 12. With 2 you can cancel out 10. We get 5 here. So finally we are left with 11 into 5 into 9. So this product comes out to be 495. So there are 495 ways in which this selection can be made. Now let us attempt the next one. So again we can mention total number of required selections. In this one we are not going to include those 3 particular players. So out of 3 we are going to select 0 player. So all the 11 are coming out of the remaining 12 players. Let us simplify it. See 3 comma 0, you can see what it will be. It will be 3 factorial over 0 factorial, then 3 minus 0 factorial, which is 3 factorial only. So 3C0 is also 1, 3C3, 3 is also 1. Okay, now moving on to the next part. This is 12 factorial over 11 factorial into 12 minus 11, which comes out to be 1 only. So the first part on simplification is 1. 12 factorial can be written as 12 into 11 factorial. This divided by 11 factorial. 1 factorial is 1 only. So cancel out 11 factorial. We are left with 1 into 12, which is equal to 12. So 12, you can see 12 selections can be made. Now children, taking another one, let us explore some more cases. See this one. It says, in how many ways can one select a cricket team of 11 out of 17 players in which 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? So let us quickly first write the given conditions. We have 17 players, and how many we are going to select? 11 to be selected. Fine. Let us break it into two parts. It says it contains 5 bowlers. Okay, if the bowlers are separated, left out players are how many? We are left with 12 players. So remaining 12. Now the question says you have to select a team of 11 which will contain exactly 4 bowlers. So if out of 5, 4 bowlers are to be selected, then to make the total 11, the remaining 7 will come out of these 12. Now we are ready to make the selections. So therefore, total number of selections is equal to, let us see how much it reduces to. It will be C 5 comma 4 into C 12 comma 7. That gives us 5 factorial over 4 factorial into 5 minus 4, 1 factorial. Here 12 factorial over 7 factorial into 12 minus 7, which comes out to be 5 factorial only. Now simplifying this, 5 factorial can be written as 5 into 4 factorial, which gets cancelled out with the 4 factorial in the denominator. 1 factorial is 1. 12 factorial can be written as 12 into 11 into 10 into 9 into 8 into 7 factorial. In the denominator we have got 7 factorial into 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1. So we see 7 factorial is getting cancelled out. 4 factorial here gets eliminated. So we have only 5 here. And this is 12 into 11 into 10 into 9 into 8. And the denominator has got 5 into 4 into 3 into 2 into 1. Cancelling out the remaining common factors in the numerator and denominator. With this 2 we can cancel out 8, we get 4. So finally we are left with 11 into 10 into 9 into 4, and the product reduces to 3960. So these many selections can be made under the given condition. Now coming to a different question now. This is not only combination, you will see it will require arrangement also, that means permutation. So go through the question carefully. It says how many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word daughter. If you count the number of letters here, there are 8. And if you separate the consonants and the vowels, you will see daughter contains this word contains how many vowels? See carefully. It contains 3 vowels. A, U, E. Contains 3 vowels. That is A, U, E. And remaining are consonants, you can see, and 5 consonants. 5 consonants that are D, G, H, T and R. Now the question says the 5-letter word which you are going to make, it should have 2 vowels and 3 consonants. So we need to first select the 2 vowels out of these 3 and 3 consonants out of these 5. So once that selection is being done, we are going to make words out of those. Okay. So we can write 2 vowels out of 3. 2 vowels out of 3 can be selected in C3, 2. If you will simplify it, it will come out to be 3. So in 3 ways it can be selected. In the same manner, 3 consonants out of 5 can be selected in C5, 3 ways. C5, 3 ways. This will come out to be, see how much? It will come out to be 10, because it will be 5 factorial over 3 factorial into 2 factorial, which means 5 into 4 into 3 factorial. 3 factorial gets cancelled out with the 3 factorial in the denominator. 2 factorial is 2 into 1. So with the 2 you can cancel out 4. We will get 2 here. So 5 into 2, 10. So see, in 3 ways we can select 2 vowels. In 10 ways we can select 5 consonants. Now when this selection is being done, you are having 5 letters. Now because the question says how many words, so even if 2 letters in these 5 letters get interchanged, we get a new arrangement. So not only selection will do the work, we need to arrange them to obtain a word. So therefore, total selections, total required selections till now, let us write total required selections is equal to 3 into 10, which is equal to 30. Fine. Now these 5 letters can be arranged in 5 factorial ways. So first selection is taking place and then the selected letters are getting arranged. So because we have to mention how many words can be made. So therefore total number of required words, that will be, see, two things are taking place here simultaneously. First, the required letters are getting selected and then the required letters are getting arranged. Now 5 factorial we have seen is equal to 120. So the total comes out to be 3600. So 3600 possible words can be made using the letters of this word, which contain exactly 2 vowels and 3 consonants.